Alright, so this video is going to be part one of surface area problems with parametric equations. So we have our parametric equations up on the board here. X equals cosine of cubed theta, y equals sine cubed theta, from 0 to pi over 2, and we're going to rotate this about the x-axis, okay? So that's going to give us some solid, and we want to find the surface area of that solid, okay? So what's our equation here? Well, the surface area equation for when we rotate about the x-axis is the integral from alpha to beta of 2 pi y, the square root of dx dt squared plus dy dt squared dt. Cool. So what do we have to find here to be able to actually do this integral? We need to find dx dt and dy dt. Okay, what is dx dt? Well, that is just going to be this derivative, right, which is 3 cosine squared theta times negative sine theta, right? So it's going to be negative 3 cosine squared theta sine theta. Right, we got to always remember to get that sine theta out, right? That's the derivative of the inside. That's just chain rule. Okay, and dy dt, we know that that is just going to be 3 sine squared theta cosine theta. So we can put that into our equation here. The surface area is going to equal the integral from 0 to pi over 2 of 2 pi times y, which is sine cubed theta, times the square root of, well, we can actually just probably square this right now, right? Dx dt squared is going to be, well, 9 cosine to the 4th sine squared. And then we're going to have plus 9 sine to the 4th theta cosine squared theta d theta. Alright, and what can we do with this now? I mean, this has got to get simplified somehow, right? There's got to be somehow we can get like a sine squared plus cosine squared or something. Well, there actually is, and we can factor out a 9 and a cosine squared sine squared to figure that out. Okay, so you can rewrite this as the surface area equals 2 pi, the integral from 0 to pi over 2, sine cubed theta, and then we can have the square root of 9 cosine squared theta, sine squared theta, and then what's left on the inside? Well, it's just going to be a cosine squared plus sine squared, so that's perfect. We get a cosine squared theta plus sine squared theta right here, and then d theta. Okay, well, this is 1, so this just simplifies down to 3 cosine sine. So we're going to get that the surface area is equal to 6 pi now, the integral from 0 to pi over 2, of sine to the 4th theta cosine theta d theta. Alright, just a lot of simplification all in one step, alright? So now, how do we solve this integral? Well, this is just a trig integral, right? So we take our u substitution. U is going to equal sine of theta, right? U equals sine theta, so du equals cosine theta d theta. Alright, well, when theta equals 0, u is going to equal 0, right? Sine of 0 is 0. And when theta equals pi over 2, u is going to equal 1. So now, with our substitutions, right, our bounds and our actual integrand substitutions, we can actually substitute. Surface area equals 6 pi, the integral from 0 to 1 of u to the 4th du. Alright, and now we can just integrate that. 6 pi times u to the 5th over 5, evaluated from 0 to 1. Well, of course, the 0 kills off everything, and we're going to get a 1/5 when we plug in 1. So this is just going to be equal to 6 pi over 5. And that's it. So, really, I mean, not anything too bad here. I mean, you're still going to have to probably simplify something under the radical, but yeah, all in all, pretty straightforward problem. So that's going to do it for this video. So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for parametric and polar, the explanation video for surface area with parametric equations, and the next video in the series. See you soon.